Okay, so here are clearly some ways in which our climate has changed and can change that is not related to human activity. And I would say plate tectonics in the previous section was another one that has nothing to do with human activity. It's true that the amount of solar radiation that we receive on a day-to-day basis is generally the same. But there are things throughout the period of hundreds of thousands of years that do change between the relationship does change slightly between the sun and the earth, and to change the amount of solar radiation that the earth gets at its various latitudes even, or just gets in general. And these are eccentricity, obliquity, and precession. And these three factors go together, collectively are sometimes referred to combined in what we call Milankovitch cycles. So here are some pictures of, from top to bottom, eccentricity, obliquity, and precession. And so I can't decide whether to, I think I'll talk you through these pictures, and then on the next slide there's some more text that goes along with each one of them. With regard to eccentricity, we know that all of the planets, including the Earth, orbit the Sun in an elliptical shape. And we sometimes think it seems like it's a circle, but it's not necessarily. It's not. A circle is a type of ellipse. Ellipse is like an oval, okay? And so this elliptical nature, or the eccentricity of the Earth's orbit, changes just slightly. And as that changes, then as the Earth orbits the Sun, its distance from the Sun can vary. Okay, so eccentricity. Obliquity refers to that 23.5 degree tilt. Okay, if somebody asks you how tilted is the Earth's axis of rotation, clear back from Unit 1, you would probably say 23.5 degrees. Well, it is 23.5 degrees, but there's a slight bit of play in that. And again, it changes over hundreds of thousands of years, that tilt. But as it changes, you might imagine, it also results in changing in how the solar radiation interacts with the Earth. The last one down there, actually, precession, has to do with the Earth staying tilted about 23.5 degrees, but it kind of wobbles like a top wobbles. It's called precession, and because of precession, actually, the Earth's axis of rotation, specifically its north pole of rotation, won't always point towards the North Star. You're probably familiar now that that the Earth's north axis of rotation points towards Polaris, or the north, and we call that the North Star. That won't always be the case. Like this little slide at the bottom here shows you when it's showing you precession, that actually, I can't remember how many hundreds of thousands of years it is, or tens of thousands of years, but the North Star will be Vega at some point. Okay, so eccentricity, obliquity, precession, they all go together to combine to create what we call Milankovitch cycles. Eccentricity is about 100,000 years, obliquity 21,000 years, precession 27,000 years. Okay, and they all overlap. And what that means then, with regard to climates on the Earth, is we would tend to expect global cooling periods at 19,000, 23,000, 41,000, and 100,000 years. So this is showing you, let's see, let's start with A. Well, there's not A. This is showing you temperatures, global temperatures in general, and how they have varied, but the scales are different for each one of these. This top one has a scale of millions of years, okay? So, millions of years ago, excuse me. So actually, if you want to go from most current back, you have to, millions of years ago, yeah. You have to start right here on the left, on the right, and go back millions of years ago. And that's what we have going as far as, I said temperatures, but actually I need to check that. I think that's ice coverage. And then the next one is showing you, can you kind of see some cycles here? And these perhaps might be from those three, and the combined cycle of the Milankovitch cycle we talked about before. And this one down here is the scale, both the scale, the middle and the bottom one, are thousands of years ago. Solar variability is also something, of course, that we as humans don't have anything to do with. If you watch the movie The Day After Tomorrow, when that wacky weather kicked in, one of the things they asked one of the scientists was, well, is there any change in solar output? So in other words, they were wanting to know, well, is the sun doing something funky? And the sun does something, not necessarily funky, but it does cycle through an 11 or 22 year cycle where it peaks in its activity and then it diminishes in its activity. It peaks in its activity and then diminishes. And one way we can measure if it's peaking in its activity is by the number of sunspots it has on its surface. And sunspots are just one of showing the sign that the sun is in an active phase. So actually, there's been known times, although it's very relatively periodic, there have been known times where it had an extended period of time where it had a lot of sunspots, or extended period of time where it didn't have very many. And that, in some cases, has linked up to drastic changes in climate, or I should say drastic changes in the weather on the Earth, even to the point that we called it a climate shift. So for instance, between 1645 and 1715, this 11-year cycle that the sun usually goes through, it basically was broken. So during that period of 70 years or so, there were very few sunspots. And that corresponded with a very relatively cold temperatures on Earth, called the Little Ice Age in Europe. So that, that Little Ice Age in Europe I mentioned, sometimes we call that the Maunder minimum. Minimum meaning there's a minimum or fewer amount of sunspots. So yeah, so this is showing you, sunspots from a little bit after 1600 to the year 2000. And can you definitely see it looks cyclical? It is cyclical, about 11-year cycles. We are approaching, I believe, we've been in a what we call sunspot minimum, not an extended minimum, but we've been in our minimum, and we should be kind of ramping up here in the next, I don't know, months or within the year to see more sunspots. And I don't know if you remember when we talked about the northern lights. Actually, with sunspot, if the sun is active, as indicated by sunspots, then actually we can expect to see more of those northern lights. So this is a picture of the solar disk, and those little kind of black, those dark specks are sunspots, sunspot groups we call them. This is just a close-up of a single sunspot. Isn't that cool? The sun is really pretty. It's got this kind of granulation sort of texture on it, on the surface. So here is your textbook showing you the cycle of the sun's